Okay, so today, this is Wednesday, November 7th, 11/7. Yay, Wednesday night. We are today going to solve exponential and log equations. I think first day, Wednesday, we're going to do this, and then Thursday, we're going to do the second side. Okay, so we're going to solve equations today that have an t or x in the exponent. And sometimes we need logarithms to help us solve this. Sometimes we don't. And then we're going to solve log equations. They're on the back. And then I'm going to show you how to get rid of logs when they're in the problem. Okay, so first ones. There's these first two examples are two that we've already taken on our first quiz, but they're going to be on your test next Wednesday. So I just want to make sure we know how to do those. So when x is in the exponent, when x is up there, like right here, see how x is in the exponent? Then, and the bases are the same, or you can get them the same using our family. Remember this little family sheet right here? If you can get them the same using this sheet, then you're going to do what we're going to do next. You may drop the base and kind of need another thing and solve for x. Drop the base and solve for x. Okay, so here we go. Can you make 3 and 9 both a 3? Like the 3's good the way it is. No change to this side. But how can we rewrite 9? So if you look at the 3 family, right here, see the 9? 9 is 3 squared. So I'm going to change 9 to 3 squared. Since the 3's are the same, we drop the base and we set 5x minus 3 equal to 2. Add 3 to both sides and divide by 5. So x is 1. Second side, how can I change 5 and 625 to the same base? So let's look at our 5 family. Here's our 5 family. See 625 right here? It's 5 to the 4th. So we're going to change 625 to 5 to the 4th, like that. And we have this. So what do we do with it when we have the same base? Right here, if the bases are the same, we are going to drop the base and set your exponents equal. Up here is drop the base. So basically drop the base, set exponents equal, solve for x. I didn't write that. So actually this is step 2, this is step 3, this is step 4. The first base step is get them in the same base. Get them in the same base. Then drop the base. Then set exponents equal. And then solve for x. Get them in the same base. Drop the base. Set exponents equal. Solve for x. So that's what we've done so far. We got them in the same base. Step 2, drop the base. Set exponents equal. Now solve for x. So we're going to subtract 1. And then we're going to divide by negative 2. So x equals negative 3/2. Guys, good? Oh, you know what? I just realized something. What did I mess up on, guys? I'm looking over my problem. This was a 4x. I only have a 4 here. Gotta go back. Forgive me. This is 1 minus 2x equals 4x. So this is not negative 3/2. All right, sorry about that. Let's go back to this. Drop the bases. 1 minus 2x equals 4x. I only said it equal to 4 the first time. So we got to get the x's on the same side. So add 2x. I apologize. And then divide by 6. So x equals 1/6. That is the answer. So now, why is this different than what we're doing today? So today, when x is in the exponent, and the bases are different, that means you can't use the family sheet. Okay? They're different. That means family tree, the family base is not going to work. So when the bases are different, you're going to take the log. You can take the log or the natural log of each side. We're going to take the natural log of each side. It's easier. They're both easy because you have two keys on your calculator. You have the log key and you have the natural log key. So it doesn't matter which one, but the natural log key works for everything. So we're going to use natural log key, and that way, why is this not showing up now? Oh, there. We're going to take the natural log of each side. So the steps, you're going to take not the common log, I'm going to cross this off. I'm going to say the natural log of each side. Apply the power property to bring the exponent down, and then divide both sides by log b to solve for x. Let's take that slowly. Here we go. So example 2a. Notice that the 7 cannot be written as a 3. There's no way I can change 7 to a 3. So that means our exponents, or bases, are going to be different. Bases are different. So when bases are different, what you're going to do is you're going to take the natural log of 3 to the x, and then you're going to take the natural log of 7. So you're taking the natural log of each side. So there's your 3x and there's your 7. They're still there. But whatever you do to one side, you have to do to the other. Now, that's the first step. That's this step. Take the natural log of each side. Second step is apply the power property to bring the exponent down. The reason we're doing this is to take this exponent out front of the natural log. So it's x times natural log of 3 equals natural log of 7. Okay, so an exponent can become a factor if there's a log in front of it. Like if I just had a 3 to the x like this, I am not allowed to bring the x out front. That's impossible. I can only do this if there's a natural log or a log. As long as you have a log out front, the exponent can become a factor. Okay, so there's the exponent. It's released out front. Now, because you're multiplying here, you can divide natural log of 3 to the other side. These cancel. Natural log of 3 is just an ugly decimal. So I'm going to put parentheses in here because when you punch this in the calculator, you're going to see parentheses. You just have to remember, I'm going to put this one in blue so you don't forget, or black. Don't forget that parenthesis. That's the only way you'll make a mistake on this problem. All right, ready? So I'm going to clear all this out. We're going to press natural log right here. Natural log of 7. Now look, see what I have right here? I have to close that parenthesis before I press divide. And now I'm going to press natural log of 3. Close your parenthesis and press equals, and there's your answer. 1.7712, 4 decimal places. 1.7712. Answer. Next one. So I obviously can't change 11 to base e, so we're going to take the natural log of the first one, and we're going to take the natural log of the second side. Now what that does is it releases this. This comes out front. Now when you have a binomial like this, it comes out front in parentheses because it's more than one term. So it's 5 minus x times the natural log of e. Now I'm going to show you guys something real quick. I want everyone to press natural log right here. Then I want you to press second. And then I want you to press divide. So I want you to bring the e up. There's the divide right there. See the e right above it? So you see how that's on my screen right now? What is the natural log of e? This you should know. If you press enter, it is 1. Anytime you see the natural log of e, do you see this right here? It's a 1. That means I don't really need it in the next step. Kind of just goes away. So then you just take that 5 minus x, and then now I don't need the parentheses anymore because there's nothing there with it. So you have this. So we're solving for x. So I want everyone to subtract 5. We'll bring it up here. So you have negative x equals natural log of 11. And then I want you to divide both sides by negative 1. Now, this doesn't mean that this is a natural log of a negative 11. It's actually only natural log of 11. Press that first. There's natural log of 11. Press enter. Then divide by negative 1. So it's negative 2.397. Looks like that 8 is going to become a 9. 2.3979. Answer. So the next one. What can we do to both sides here? We can't get the 3 and the 4 to be the same base, so we're going to take the natural log of both sides. Because this is a binomial, when I bring it out front, it comes out front in parentheses. Now this time, the natural log of 4 is not going to cancel out. Only the natural log of e cancels out. So this one's going to take 3 steps. First, I'm going to get rid of this. Then I'm going to get rid of the 7. And then I'm going to get rid of the 2. Okay, because your goal is to solve for x. So first, we're going to divide by natural log of 4. So right, I'm going to have 2x plus 7, because this cancels, equals. Now you can leave it like that throughout the problem, or you can actually change it over to a decimal. Some people prefer just to go ahead and change it to a decimal. So natural log of 3 divided by natural log of 4 is this. So it's 0.7925. You with me? Now leave this on your screen. I'm just going to write 4 decimal places of this. Let this. It's not reading that. Oh, it must not like these pens. Why is that not clearing up? Sorry guys, it's really blurry. I don't know why. I'm trying to focus in on it. Let me change something up here. I don't know why this. Oh, there it goes. Wait. Why won't this focus? It's not. Why is this not focusing? I'm getting mad. There it goes. All right. Okay, wasn't liking something. Okay, I want everyone to subtract 7. Now notice on your calculator, we've already got this on our calculator from the last time. So just press minus 7. It says answer minus 7. So it's negative 6.2075. Obviously, it doesn't like when I go from calculator to paper. Equals 2x, and then divide that by 2. Your answer is negative 3.1038 when you round it to 4 decimal places. Okay, next one. D. Take the natural log of both sides. What are we going to do with this 2x? It's going to release out front. Now, everybody, can you guys tell me what natural log of e is? Natural log of e is 1. So just cross it out. So now just bring down the 2x equals natural log of 10. And we're solving for x, so divide by 2. Now, this is not the natural log of 5. Do not mistake that. This is not the natural log of 5. You're not allowed to divide those numbers. So this is the natural log of 10 divided by 2, which is 1.513. Wait a minute, 5. Wait a minute, let's do that again. 1.1513. Answer. On the back. It's going to be probably day 2, but I'm still going to go. When there's a log on the left and the right, when there's a log on the left oh, wait a minute. Sorry guys. When there's logs on the left, I'm trying to figure out what that's supposed to say. There's a log on the left and I don't know what this is supposed to be. When there's a log on the left and right, you may drop the log. When there's logs on the left and right, you may drop the log. I don't know what that third line was supposed to be. I don't know what this is supposed to be. I'm drawing a blank here. It is a blank. So do you guys see this? Now it does say you may need to condense to have a single log on one side. And they must have the same base to do this. That's going to happen in B. But in A, do you see how you have a log on the left-hand side and a log on the right-hand side? As long as there's no number out front of these, you can drop these. You're just going to drop them. As long as they have the same base, you can drop them. And you're going to set x plus 6 equal to 2x minus 5. So you're going to drop the log. And then you're going to solve for x. So if we're solving for x, let's subtract an x. And then add a 5. So x is 11. That's it. Now this one's harder. Count that there are 3 logs. You're not allowed to have 3. You can't drop the log with, you can't drop 3 of them. You can only drop 1 from each side. You can't drop 2 from one side. So what you have to do is condense. Now we did this in the last set of notes. Who knows what you do when you have a subtraction? If you're saying divide, you are right. Divide. X plus 6 divided by x equals log base 9, 2. So we divide these two, but you write the single log. So now notice you have a single log on the left and a single log on the right. And these will cancel. And you set x plus 6 over x equal to 2. Now let's put that 2 over 1. Make it a proportion and cross multiply. So x plus 6 equals 2x. Subtract the next to the other side, and x equals 6. So when there's a log on one side of the equation, we are going to swoop. Forget these. On one side of the equation, we're going to swoop. So we're going to condense logs if necessary. So this is steps to solve a log on one side. If you have a log on one side, condense logs if necessary to get a single log. Swoop to change the exponential form. Solve for x. So this is a single log, so we're going to swoop. 4 squared equals x minus 2. Add 2 to the other side, and 16 plus 2 is 18. On this one, you have to condense. There's 2 on one side, so we're going to go log 2. We are going to multiply x and x minus 1 because of the plus sign. So when you have a plus, you multiply. If they're on the same side, you have to condense them. And it equals 1. So this is still considered logs on one side. But if you have 2 on one side, condense them. So in this one, we have to multiply them. And the problem before, because of the minus, we had to divide them. But if you're having a plus, you have to multiply them. So anyway, we're going to swoop. So it's 2 to the first equals x times x minus 1, which is a little bit harder than the last one because we have to distribute the x to get this. Then you have to subtract 2 to the other side to get a trinomial. Then you have to factor. Factors of -2 that add up to -1 are -2 and 1. Set each one of these equal to 0. And you get x equals 2 and x equals -1. So something I don't know that I've even told you is you can never take a log of a negative number. So the negatives never work in these problems. Well, I wouldn't say never, 99% of the time. The 2 will work because if you put a 2 in there, it's 2. If you plug a 2 in this, 2 minus 1 is 1. As long as it's not a negative or 0, you're good. X is 2. So in this problem, you guys see that you have to condense? You see how you have 2 on one side? 2 on one side. So we're going to condense. So it's log of x plus 2. Because of the minus, we're going to divide by x and set this equal to 2. Now, what is the base if they don't write one? So I want everyone to fill in a 10 right here. Fill in the 10. So we're going to swoop. 10 squared equals x plus 2 over x. 10 squared is 100 over 1 over x. We're going to cross multiply. get this. Get x's on the same side. Get this. And x is 2 over 99. Weird answer, I know. Okay, so I gotta hurry up because class is coming in. This next problem, we can't condense unless if there's a number out front. So we have to go log base 3 of x cubed. So that exponent, it can go up as an exponent or can come out as a factor. And this one we wanted to make it an exponent so we can condense. Now this is already an exponent, so that's good. Now we can condense log base 3 of x cubed. Because of the minus, we are dividing. This is log base 3 of x equals 4. The reason it's x is because you can divide those out. 3 x's on top, 2 on the bottom, you subtract them and get an x. Now we swoop 3 to the 4th equals x, and x is 81. Okay, last problem. They want us to use this formula right here. All right, A is the new computer cost. The rate that it is depreciating. The reason it's a minus is because it's depreciating at 21%, so change that to a decimal. How long will it take for a computer to be valued at $100? So we don't know what the T is, but when will it cost $100? So divide by 1,300. 100 divided, these cancel, and you get, let's see, 1 divided by 100 divided by 1,300. All right, I'll be with you in 2 seconds. I'm making you guys a video. 1.0769 equals, what's 1 minus 0.21? It's 0.79, so this is 0.79 t. Now this is a really ugly answer, but we're going to take the natural log of each side.
You can't find it.
Very good question.
So that's natural log of 0.0769 equals t natural log of 0.79. Okay, so you see over here, natural log, and bring the t out front. And then the last step is to divide both sides by the natural log of 0.79. So on your calculator, do natural log of 0.0769 divided by natural log of 0.79. 10.88. So it means it's going to take about 10.88 years. Okay, guys.